Hey everyone. So, today, by popular demand, I'm going to be talking about the five main types of reactions. Okay, so chemical reactions can be broken down into many different types. Today, I'm going to be talking about five of the most common types. Now, I'm going to be talking about what their key characteristics are and how you can easily identify these different types of chemical reactions if you're just looking at the formula. Okay, so the first one that we're talking about is synthesis. Okay, synthesis is anytime you have two reactants, so you're starting with two different things, and you're ending with one product. Okay, that's kind of synthesis in its simplest form. Now, if we're talking about the generic equation for synthesis, the generic equation, actually, I want it to be a little bit more narrow. Let's try that. No, not happy with that either. There we go. So the generic equation for synthesis is commonly written as A plus B becomes AB. Now remember, we use plus signs in chemical reactions to indicate when you're dealing with two different substances. So we can see on our reactant side, that's our left side, that we have two different substances. And after our reaction, at the end, following the arrow, we have one substance that has combined both of the original reactants into one new compound. So, generally speaking, you're going to be starting with two substances and you're going to be ending with a new compound. Now, a real world example of this might be something like this. So, let's put an example. Okay. The example would be aluminum and oxygen becoming aluminum oxide. Let's balance this up for the sake of correctness. 2, 3, 4. So you can see, that we have two different reactants, aluminum and oxygen, and following the reaction, they combine into one new compound. This is synthesis, okay? So we've got two things becoming one thing, okay? So if you're trying to identify synthesis, look for this pattern. Two things becoming one, okay? Let's talk about the next one. Next one we're going to work on is decomposition. Now, decomposition is actually very much the exact opposite of synthesis. So, synthesis was two reactants combining to make one product. In decomposition, you have the opposite. You have one reactant, one compound, splitting apart to make two different products. So, the generic equation is going to look like the reverse of the previous one. Okay, my generic equation is going to be AB becomes A plus B. So if we compare these two, right, for synthesis, we had A plus B becomes AB. For decomposition, because it's the opposite, we have they just flip sides. We have the compound AB becoming A plus B. Okay? And so similarly, our example could be literally the exact opposite of what we did before. 2 Al2O3 becomes 4Al plus 3O2. So we have our aluminum oxide compound reacting and splitting apart to form aluminum and oxygen. This is decomposition. Okay. Next one, combustion. Now, combustion is basically any reaction in which some kind of compound or element is reacting with oxygen and forming a new oxygenated or oxidized compound. Now, for the purposes of this class, we're mostly focusing on when we burn some kind of what are called hydrocarbons. Hydrocarbons are just compounds made of carbon and hydrogen. Okay. So, because of this class, because we're focusing on hydrocarbons, our combustion reactions are going to always produce two distinct products. They're always going to form carbon dioxide and water. That's just how these reactions work. So, for our generic equation, okay, we're going to have our compound. In this case, this is going to be some hydrocarbon. So, like methane, ethane, propanol, anything that involves carbon and hydrogen, basically. So, we're going to have our compound. Now, the first hallmark of a combustion reaction is that it has to react with oxygen, okay, with O2. Oxygen by itself must be one of the reactants for it to be a combustion reaction. Okay. Now, as a result of this reaction, you're going to form some kind of oxidized compound. An oxidized compound just means it's a compound that involves oxygen. Now, because we're dealing with just hydrocarbons here, our oxidized compound is going to be carbon dioxide. So again, this is an oxidized compound because it's got oxygen in the compound. It's going to form carbon dioxide and it's going to form water. Okay, so this is the most universal indication of a combustion reaction. It has to have oxygen at the beginning of the reaction. For the purposes of this class, okay, the other things that you can look for is forming carbon dioxide and forming water as products, okay? You have to have these three things for it to be a combustion reaction, okay? So an example of this, let's do the burning of methane. So methane is CH4. Again, this is a hydrocarbon because it involves carbon and hydrogen. So methane reacts with oxygen to form carbon dioxide and water. And let's balance that out. This has got to be a 2. And then that's 2, 4 oxygens. That means this has to be a 2 as well. Okay? So this is our balanced chemical equation for the combustion of methane. You can see we're starting with oxygen, and we're forming carbon dioxide and water. So this is an example of a combustion reaction. Okay? Next, single replacement. Okay? A single replacement reaction is a reaction between a compound and an element. Okay, so make a little note. So for a single replacement reaction, you must start with an element and a compound. Now, before I get a little bit more into this, I'm going to start writing out the generic equation because sometimes it's a little bit easier to understand this one if you're diagramming it out. Okay. So the first part of my generic equation is going to be A plus BC. So A is my element because it's all by itself. BC is my compound because I've got two elements stuck together. Now, in a single replacement reaction, the element, in this case element A, replaces whatever matches from the compound. So this compound is generally an ionic compound, so it's got a positive and negative charge. So if the element here is going to form a positive charge, like it's a metal, right, replacing another metal, A will replace B. It'll take its spot. So A take the spot of B. And when this happens, B will get kicked out and it'll be by itself. So following the reaction, you'll end up with AC plus B. So you see how A now is in B's spot. It's attached to element C, forming AC. And B is kicked out and it's by itself. Okay? This is what's called a single replacement reaction. Okay? Because a single element is being replaced into a compound. Okay? Now, this is kind of the diagram of if it was like a metal replacing a metal. But this can also happen with like a non-metal replacing a non-metal. So like let's say A was going to be forming a negative charge, A would replace C and you'd get compound BA and C would be kicked out. Okay? It really depends on whether you're replacing a metal or a non-metal. Okay? So, an example of this would be, let's take it from our lab, aluminum plus copper chloride becomes aluminum chloride plus copper. And if we balance this out, this has to be a 2, this has to be a 3, this has to be a 2, and this has to be a 3. Okay? So you can see aluminum switches out with copper. Aluminum becomes bound to the chlorines and forms aluminum chloride, and copper is ejected and it forms the elemental form. Now in our lab, we saw this because we had the blue copper chloride solution, and when we added the aluminum foil, the aluminum replaces the copper, and you start to very quickly see a brown, like copper substance, solid start to form out of the liquid. Okay, that is copper being replaced in the solution. Okay, so this is our single replacement reaction. Now let's look at a double replacement reaction. Okay, so a double replacement reaction is very similar to single replacement, except it involves two compounds. Okay, so double replacement must start with two compounds. Okay, and again, just like single replacement, I'm going to start by writing the first half of the generic formula. So our generic equation is AB plus CD. Okay, so we've got two compounds, compound AB and compound CD. Okay, now in these compounds, these are both ionic compounds. So you have a positive and you have a negative charge. Okay. What's going to happen is the cations of both of these compounds, remember the cation is written first, okay? The cations are going to switch places. So A is going to switch places with C. But unlike single replacement, where C is just kicked out and it's by itself, C is going to swap into A's old spot. So as a result, you end up with compound CB plus compound AD. Okay. Element C is swapping into A's spot, so it becomes CB. And element A is swapping into C's spot, forming AD. Okay. Now, let's look at an example of this. Okay, an example of this would be a neutralization reaction. So let's say we have hydrochloric acid plus sodium hydroxide. Okay. So hydrogen and sodium are positively charged. Chlorine is negatively charged. And this OH right here is actually a polyatomic ion. Remember, polyatomic ions are elements that are covalently bonded that act as one piece. In this case, hydroxide right here, OH, has a -1 charge. Okay, so hydrogen is going to swap into sodium spot, and sodium is going to swap into hydrogen spot. So we're going to form sodium chloride. Sodium switches into hydrogen's old spot. Hydrogen is going to swap into sodium's old spot. So we're going to have one H right here and then an OH right here. HOH. That's two H's and one O. So you could rewrite that as H2O. That's water. Okay. Now, there's a couple key facets to double replacement reactions which make them easy to observe. They have to start with two compounds. That's kind of the easiest one to see. Okay. The compounds have to switch places. And another thing is they must form either a solid, a gas, or water. Okay. Double replacement reactions must form a solid, a gas, or water. So you might see a solid marked with a little S like this, gas marked with a little G like this, or water if you see H2O. Okay. So let's recap real quick. Okay. Just kind of try and get this all on one screen real quick. Okay. So first, synthesis. It's two things becoming one. So AB becomes AB. So A plus B becomes AB. Decomposition. One thing splits into two. Combustion. You start with a compound reacting with oxygen. And if we're doing hydrocarbons, which we're mostly doing in this class, you're going to form carbon dioxide and water. Single replacement, you have to start with an element and a compound. Okay, so be looking for that. The element switches places with one of the elements in the compound. So you end up with a new element and a new compound. Double replacement, you have to start with two compounds. The cations, the ones listed first, switch places with each other to form two new compounds. Okay, like that. And they must form either a solid, a gas, or water.